So this one is again summarizing curve sketching, but this time with a transcendental function, natural log of x. So we've got the first derivative is going to use the quotient rule, which means the denominator needs to be squared. Take the derivative of the numerator, which is 1 over x, times the denominator left alone, minus the numerator left alone, and multiply with the derivative of x. Always check to find out, is there any place where the derivative is undefined, and that is where x equals 0. So the derivative does not exist at x equals 0, so something important could be happening to the graph there. Or perhaps the graph just doesn't even exist. The function doesn't exist there. Thus, the derivative can't exist there. And then the other thing to do is find out where does the derivative equal 0. So this is going to be a 1 minus the natural log of x. Technically, I'm supposed to put the absolute value of x, but if you just realize that the natural log of a negative doesn't exist when talking about real numbers, then you don't have to put that. You can just put natural log of x and just understand x is positive. So natural log of x equals 1. You could then exponentiate both sides, and the answer is e. So something is happening at 0, namely the function and the derivative do not exist, and there's something happening at e, namely the derivative equals 0. So the derivative, when simplified, equals 1 minus the natural log of x over x squared. So pick a number that's in this interval, something easy like 1 would be nice, and substitute that into the function. So we'd have, well, the natural log of 1 is 0, so we just have 1 divided by 1 squared is 1, so that's positive. So it seems that the function is going up in that region. E is 2.718, so if I pick something like 3, that would be over here. So we would need 1 minus the natural log of 3 gets divided by 3 squared. It's negative. So on this side, it's going down. So it was going up and then going down. So we've got a maximum. So right here, there's a maximum. So E, and then substitute to find out what the y value should be. Well, natural log of E, that's 1. They cancel each other out. Natural log of E to the 1. So that would be a 1 divided by E. So there's the maximum value. In here, it's increasing. So that's going to be from 0, but don't include it, to E and don't include it. And then decreasing on the right-hand side, so from E to infinity. And now we're ready for the second derivative. So I'll use this. Here's the first derivative. Take the derivative of that. So the denominator needs to be squared. So it's going to be squared squared, means to the fourth. Then take the derivative of this. So that's going to be 0 and negative 1 over x. So there's the derivative of the numerator. And then the denominator is x squared. Next, it's going to be minus, leave the numerator alone, 1 minus the natural log of x, and then gets multiplied with the derivative of x squared. So always check to see where it's undefined, which is at x equals 0, but we've already established the function doesn't even exist at x equals 0. Then find out where the second derivative equals 0. So this would be negative x. And then I should distribute this, so it's going to be negative 2x. And then negative and negative will make positive 2x times natural log of x. So these combine to be negative and then plus 2x natural log of x. And then because it's got an x and an x, I could factor that out. So negative 3 plus a 2 natural log of x. Well, once it's factored, set each factor equal to 0, so that's going to give us the answer x equals 0, which we already know the function's not defined there. And then this will be set it equal to 0 and move that over. It's going to be 2, the natural log of x equals a 3. Or in other words, natural log of x equals 3 over 2. To get rid of natural log, exponentiate both sides. So it's going to be e raised to the 3 over 2. So it's going to be much like this graph. For the second derivative, we have at 0, it does not exist. At e to the 3 halves, it equals 0. And from this algebra in here, we've got the second derivative equals an x times negative 3 plus 2 natural log of x divided by x to the 4th. And then just pick some numbers, like again, well, this is e and it's raised to something more than 1, so that means it's more than e, so a 1 should work. And if you substitute a 1 in, natural log of 1 is 0, so that's gone. This would be a 1 times negative 3, so negative 3 divided by a 1, so negative. And then pick something over here, so I better just double check. E to the 3 divided by 2 is a 4 point something, so I could pick 5. And then substitute a 5 into this. It turns out to be positive. So this is concave down. And over here would be concave up. So from e to the 3 over 2 to infinity. And double check. So it's natural log of x divided by x. So the function has an asymptote. It was down here at negative infinity. So there's an asymptote at 0 because it's undefined there. Vertical asymptote. And then also notice that it leveled off, so there is a horizontal asymptote. We'll need to find that after checking these. So I need to zoom in a little bit. Let's see, I don't need any negatives. Going out to 5 should probably do it. And from, let's say, -3 to +3. How's that look? Pretty good. So it looks like the maximum is right around in here. What did we find? We found the maximum is supposed to be at E. So trace and put an E to the 1. That sounds reasonable. And then they say the Y value is 0.368, so 1 divided by E, too many parentheses, is 0.368, so that's right. And it's increasing from 0 to E and decreasing after that. So this stuff is correct. And over here, concave down, so this is concave down. And then actually that right there looks like it's concave up because it's going from a maximum and then going down, so it's possible that's where it's concave up. But the math tells us it's actually at E to the 3/2. So trace and E to the 3/2 is where it's changing. So all of this is concave down, and then after that it's going to be concave up. And finally, what about asymptote? So we've got the vertical asymptote. Now what about as x goes off to infinity? So in other words, the right hand side of the graph looked like it was either leveling off at something small or perhaps 0. So we need to find out where it's leveling off as x goes off to the right. So in other words, what's the limit as x goes to infinity of the natural log of x over x? Natural log of infinity is infinity. This would be infinity, so it's time for L'Hopital's rule. Basically, it's a race. Which one gets to infinity faster? Natural log or just the x function? Well, the derivative of the x function is a 1. The derivative of natural log of x is 1 over x. So now we would have 1 divided by infinity, which is 0. So this function is actually getting closer and closer and closer to the x-axis. Or in other words, we've got a horizontal asymptote the x-axis, which is y equals 0.